Hello. Hey. No, hi. Yeah, no. Now's a good time. It's going great. It's going really well. I mean, YouTube, the whole thing. It's really been a learning experience. Yeah. No, good response. Strange, but what are you gonna do? We're all doing our best. What? Get bacon mug? Oh, no. I mean, yeah, he's right here. You want to say hi? Yeah. No. Yeah. What? Say that again. Sponsorship. Other novelty mugs. I mean, I really appreciate it, but he and I have been together in this thing since the beginning. It's a package deal. How how much? No, I heard you. I heard you. Oh, well, look, definitely something that we could talk about. I I will definitely give it some thought. Good talking to you too. All right. Bye bye. All right, guys. First off, I want to keep things relatively simple for today. What we're going to do is mainly just review the material from yesterday in a more practical way. I hope everybody can see this all right. I do want to let you know that the main focus for today is going to be to get the quiz done. That's really your homework for tonight. So make sure in that regard that you log on to take the quiz. You'll have 2 attempts. Remember, that's going to cover the homework from Thursday and Friday. If you have not, or if you're watching this video early enough, excuse me, if it's before 10 in the morning, be aware that at 10 this morning, I will be available for live conferencing until 10:30. So if you have any questions about this stuff, or you have any questions about what's going to be on the quiz, you can meet me there. And if you look at yesterday's video, you'll be able to see where and how to access both that information and how to get to the conferences itself. So guys, with these transformations, hopefully you've been able to start to see, as you looked at that set of transformation techniques, that we're going to follow a set of steps. And there's 2 ways to think about this. There's the way I want you to think about it, and then there's the way my math lab is going to actually have you attack the problems. So I'd like to just very quickly deal with both. So actually I'm pulling this one. This one is my version of number 3 from yesterday's homework. So they're asking us to do the transformations necessary to be able to transform the graph of -3 to the x plus 2 power. So a great place to start in every case is to begin with whatever the original or most base version of that function is going to be. So here is f of x equals 3 to the x. And what I recommend everybody do, and the homework actually kind of has you do this as well, is it gives you some points to work with. But I just kind of want you to be able to visualize, what that function looks like. So in my version, and in yours too, they're generally always going to give you -1, 0, and 1. Now I went ahead and did 2 here just so you can get the idea. My guess is nobody has any problems with this, and everybody for the most part is able to determine why and how that looks like this. And once again, I cannot stress enough the topicality of this discussion. I'm going to try to avoid any outside commentary, but as you could probably guess, most of your life right now revolves around curves that look kind of like this. So be aware that the math is very sound on this. So here's our 4 points. Here's what that translates into. We can imagine that curve going further and further towards infinity in a positive direction once we get past the y-axis and we're moving in the positive direction on the x side. So how do we attack this? So disregard this one in the middle for a second. I'm going to come to this in a minute. If you really just want to get an idea of what a transformation of a function looks like, then I recommend just plugging some of the same points in. Now, I cannot stress this enough because this is going to change the math. There's a negative sign in number 3. I want you to be aware that even though it's not in parentheses, you can kind of think of it as all of this then making that negative. So in a sense, just like we flipped our waves when we had a negative sign, some of you might have worked with this one and actually treated this as -3, which when you had odd numbered exponents would cause all of our y values to get a little squirrely. I hope you understand what I mean when I'm saying this. We would have a negative version, then we'd have a positive version, then we'd have a negative version, then we'd have a positive version every time we had an even exponent. Do not think of this like this. We're going to do all of this computation first, then we're going to make that value negative. That really is what causes that reflection about the x-axis. And if you look over here, you should already be able to see there's a kind of reflection. So if we go with that same -1, we plug it in, -1 plus 2 is +1, 3 to the first power is 3, and then the negative version of that is -3. Here, 0 plus 2 gives us 3 squared, that's 9, negative version, -9, and so on and so forth. That's going to allow you to get the shape. But if you notice, you'll be able to get a basic sense of what the transformations are. You can do this in Desmos as well if you want to verify this. Now that said, Schoology, my math lab, asked you to do something just a little different. They're going to ask you for the corresponding points. So this really isn't going to work. This is going to give you the shape. What they're going to say is, okay, what is the corresponding point for -1 in this case? In other words, if I pick up this point and I put it through its transformation, what is it going to give me on the back side? So here is where having an order is really important. So let me explain. We have an x value of -1 here. If we look at what this means, remember, if we look at our rules, adding or subtracting in the exponent gives us a horizontal shift. And I said yesterday that that shift is reversed. So since we're adding 2 here to the exponent, that means we're going to be shifting 2 units to the left. So that is where we get this new x value from. So we look at it, okay? We go, okay, I'm shifting this 2 units to the left, so I know my x value is going to be -3 in this case. Then once I'm done with that, I can just do everything as normal. So -3 plus 2 is -1. 3 to the -1 is 1/3, and then make that negative, and you get -1/3. It's just important to have a set of steps and a process there. That's why we're taking this so slowly. We're going to do another day tomorrow where we talk more specifically about more complex examples of this. So, 2 ways I want you to attack this. 1, you can plug on your own just to get an idea of what an equation looks like. But within my math lab, you've actually got to do the corresponding points in general for -1, 0, and 1. To do that, just look at what the equation does, then follow its steps. In this case, since I'm shifting 2 units to the left, I started there and then put everything back in the function from that point on. Remember, no homework over this tonight, but I recommend that you look over it and try to get yourself a better understanding. Quiz tonight, you have 2 attempts. Good luck with that, and with everything else that you have going on for the rest of the day.
Golden brown, fine temptress, through the ages she's heading west. From far away, stays for a day, never a frown.